Friends. So now in this video we solve this example. So the question is that find the maximum value and the minimum value of this function. So that is the function is given by f of xy is equals to x cube plus y cube minus 3x minus 12y plus 20. So we have to find the maximum value and the minimum value of this function. So see here. So what is given here? F of xy is equals to x cube plus y cube minus 3x minus 12y plus 20. So this is what the given function is. So first take the partial derivative of this function with respect to x, that is fx of x comma y. So this means partial derivative of f with respect to x. So that is given by, so derivative of x cube is 3x square, y cube is 0. Is it clear? Minus 3 into x derivative is 1 only, so therefore 3 we have, and also minus 12y. Here also derivative of y with respect to x is 0, and last 20 it is also 0, and fy, this is partial derivative of f with respect to y. So that is equals to derivative of x cube is 0, y cube is 3 y square minus 3x is 0 minus 12y is 12 only, and 12 plus 20 is also again 0. So these are the partial derivatives of f with respect to x, and this one is with respect to y. So now we got the partial derivatives. Now consider to find stationary points. So now stationary points. So after taking the partial derivatives of f with respect to x and y, so we have to find the stationary points. Means, so where these are the points, stationary points are the points where we may get the maximum or minimum value of this function. Is it clear? How to find the stationary points? So to find the stationary points, we have to equate the partial derivative values to 0. So that is fx is equals to 0. So what is the value of fx is? Fx means partial derivative of f with respect to x. What is the value of fx is 3x square minus 3. That is equals to 0, and fy is equals to 0. What is fy value is 3y square minus 12 is equals to 0. So now solve this one for x and this one for y. So solve them. So what we will get here? So if you take 3 common, x square minus 1. X square minus 1 is equals to 0. Divide both sides by 3. What you will get? X square minus 1 is equal to 0. So solutions are x is equals to x square is equals to 1. Take this minus 1 to RHS. You will get x square is equals to 1. So x becomes plus minus 1. And here also, and so here, so take 3 common here. Y square minus 4 is equals to 0. Divide both sides by 3. What you will get? Y square minus 4 is equals to 0. Y square is equals to 4. Y is equals to plus minus 2. Is it clear? So this is what the value of y, that is plus minus 2, and x is equals to plus minus 1 we got. So now x is equals to 1 comma minus 1 and y is equals to 2 comma minus 2 we have. So now the stationary points are given by, we have to combine the value of x with respect to with value of y, that is, so combine this x is equals to 1 with y is equals to 2. So therefore stationary points are combine this 1 to 2, that is 1 comma 2, 1 with minus 2, that is 1 comma minus 2, then second value of x with first value of y, that is minus 1 comma 2, and minus 1 comma minus 2, that is second value of x with second value of y, minus 1 comma minus 2. Is it clear? So these are what the stationary points are. So after finding the stationary points, so we have to consider the second order partial derivatives. Now fx, this means partial derivative of fx with respect to x, means fxx, that is equals to, so differentiate the fx with respect to x again. This is what the value of fx. So again differentiate this one with respect to x. What we will get? 6x. So consider this one as capital A value. Similarly, fxy, that is equals to fxy, means either you can differentiate fx with respect to y, or you can differentiate fy with respect to x. Is it clear? So now differentiate fy with respect to x. What you will get? fy with respect to x means, so this is what the value of fy is. So if you differentiate this one with respect to x, you will get 0. Otherwise you can differentiate fx with respect to y, that is here also there is no y terms. If you differentiate fx with respect to y, so this term also becomes 0. So therefore fxy is 0. So that is consider b. Is it clear? So similarly fyy means differentiate fy with respect to y. What is the value of fy is? Fy is 3y square minus 12. If you differentiate again this one with respect to y, what we will get? 6y. So this is what the value of fyy. So consider this one as capital C. Is it clear, students? So after finding the stationary points, we have to find the second order partial derivatives of f with respect to x, y, then y. That is fxx, fxy, fyy. Is it clear? So consider them as A, B, C. Now see. So after finding the stationary point, so we have to consider the table. So it is very much easy to make the table. So always make the table. So how to make the table? So here consider the stationary points. What are the stationary points here? 1, 2, 1, minus 2, minus 1, 2, minus 1, minus 2. So total 4 stationary points we have here. That is 1, 2, 1, minus 2, minus 1, 2, minus 1, minus 2. Total 4 stationary points we have here. Similarly, we have to consider the here a is equals to, what is the value of a is equals to? That is fxx, that is 6x, that is a. So similarly fyy, that is 0, that is b. So this one is xy. xy is equals to b, fyy is equals to 6y, that is capital C. So now, so after considering the stationary point, substitute this point into here. Substitute this point into a value. So what is the value of a when x is equals to 1? So here we have a 6x. So 6 into, what is the value of x in this point? 1. So 6 into 1 is 6. So whether it is greater than 0 or less than 0, that is obviously greater than 0. So here also this one is greater than 0. This one is minus 6, that is less than 0. Minus 6, that is less than 0. So similarly b value. So b value is already 0. So it's not need to find the value. So therefore it is 0 only. In all the cases that is 0 only. And similarly 6y. Again it is 6y. At this point y value is 2. So 6y becomes 12 here. So similarly here also 6 into y. So y value is minus 2. This becomes minus 2. So here also 6 into minus 1, that is 6 into y, that is y is 2, that is 12. So here also 6 into minus 2, that is minus 12. So last, consider the Hessian determinant value. So this one is known as Hessian determinant. So AC minus B square, that is known as Hessian determinant value. So that is given by AC minus B square. AC minus B square means A into C, that is 6 into 12 are 72, minus b value is 0 here, b square. So that is 72. So whether 72 is greater than 0 or less than 0, that is obviously greater than 0. So in this column, AC minus B square, A into C minus 72, that is less than 0 we got. Here also minus 72 less than 0 we got, and here also 72, that is greater than 0. Is it clear? So we got 4 values, 4 Hessian determinant values. Is it clear? Now see. So here in this column, Hessian determinant value is greater than 0. Hessian determinant value is greater than 0, and A value is also greater than 0. Hessian determinant value is greater than 0 and A value is also greater than 0 means, so this is what the point of minimum. So if AC minus B square is greater than 0 and A value is also greater than 0, this point is, that respective point is known as point of minimum. So point of minimum. This value is not the minimum value. So this point is the point of minimum. Means we will get the minimum value at 1, 2 point. So similarly here. So if the Hessian determinant value is directly it is less than 0. So then this is this point. So if the Hessian determinant is directly it is less than 0. So if Hessian determinant value is directly less than 0, then we call this point as the saddle point. So that is So if the Hessian determinant value is directly less than 0, that is if it is negative, Hessian determinant value is negative, so then that respective point is known as saddle point. So here also Hessian determinant value is minus 72, so that this point is saddle point again, saddle point. So here also, but here 72, that is positive 72 we got here, that is Hessian determinant value is greater than 0 and A value is less than 0. Here this point is maximum point, that is point of maximum, point of maxima or point of maximum. So therefore the maximum value of f is at, what is the maximum value of f is at, means f attains its maximum value at the point minus 1 comma minus 2. This is what the point of maximum, minus 1 comma minus 2. Now if you substitute this point into the given original function, so we'll get the value of maximum value, we'll get the maximum value of the given function. So and the maximum value of f is, so substitute the point f of x comma y at the point minus 1 comma minus 2. Substitute the point minus 1 cube plus minus 2 cube minus 3 into minus 1 minus 12 into minus 2 plus 20. So if you simplify this one, minus 1 minus 8, so plus 3 plus 24 plus 20. So what is the value of this one? So 48 minus 9, that is 48 minus 9 is 48 minus 9. What is the value of 48 minus 9 is, this is 38. So this is what the maximum value of this function, so which is attained at the point minus 1 comma minus 2. Similarly minimum value, sorry, minimum point is, what is the minimum point here? Point of minimum, that is 1 comma 2. Minimum point is 1 comma 2. So and also minimum value of f of x comma y is, so it is the minimum value f of x comma y at 1 comma 2, that is what the minimum value is. So substitute the values, 1 cube plus 2 cube minus 3 into 1 minus 12 into 2 plus 20. So if you simplify this one, so what will get? 1 plus 8 minus 3 minus 24 plus 20. So if you simplify this one, what you will get? So that is 2. So this is what the minimum value. So f of x comma y at the point 1 comma 2. So we got 2. This is what the minimum value of this given function, and 38. This is what the maximum value of the given function. So that's all. This is what the solution is. F of x comma y is at 1 comma 2. This is what the minimum value. This one is the maximum value. Is it clear, students? Thank you. So if you like the video, please give it a like. Thank you.